Ethernet switching is touching close to 100 billion a year right now, and it's expected to double yet again. That's Anshul Sadana, founder and CEO of NextHop AI, talking about the part of the AI boom almost nobody brags about at dinner: the network. Welcome to X-Pulse Digest. This came from Lightspeed VP, where Guru Chahel dug into why AI data centers are forcing a new networking model and why shaving a single % off power can be worth an entire power plant's worth of headroom. And yes, there's a reason hyperscalers are suddenly open to partner as a third option. Here's a quick gut check that resets the scale. If someone tells you $1 billion data center is going up, how much of that is networking? The answer in this conversation is 10 to 15%. So call it $100 to $150 million per billion just on networking gear. That's the quiet engine behind a roughly $100 billion switching market today. And the claim isn't, "This is mature, congrats everyone." It's the opposite. The expectation is another doubling over the next decade, which is wild for something most people treat like plumbing. The punchline is not just that the market is large, it's that the customers are now large, in a "we have to change how we sell" kind of way. In the investor mental model, you hear hyperscalers, like it's one bucket. In Anshul's framing, Microsoft is a market. Meta is a market. Google is a market. They're each big enough to justify their own custom physics. For the last 2 decades, hyperscalers basically had 2 ways to source networking. One is the OEM model. You buy a proprietary hardware plus software stack from a big networking company, names like Cisco, Arista, Juniper, NVIDIA. The other is the DIY ODM model. A hyperscaler takes merchant silicon, like a Broadcom chip, designs hardware internally, writes their own network software, then uses an ODM, typically in Taiwan, to manufacture the switch. If you're wondering why anyone takes on the pain of building their own switches, the answer here isn't cheaper. The primary motivation is going faster than the industry, baking in their own secret sauce, their own operational stack, their own edge. So the menu was build or buy. And then AI showed up and made both options feel oddly inadequate. In the pre-AI cadence, a new generation of switches every 3 to 4 years was a manageable heartbeat. You could do that with a relatively small internal team. With AI, the claim is you may need 8 to 10 products every year because the use cases splinter and optimization becomes relentless. A hyperscaler's internal team can't keep up with that volume, and an ODM relationship can become a resource management trap. Meanwhile, the OEM route gives you something that may not match reality inside the data center anymore. The line that sticks is brutally physical. The outside switch won't even fit because each hyperscaler's rack architecture is diverging. Liquid cooling shows up differently. Thermals differ. Mechanics differ. So the constraint isn't abstract. It's literally, does this box bolt into my environment and run inside my power and cooling envelope? And that's the opening for a new model. NextHop's bet is what they call the joint development model, also referred to as the GDM model in the conversation. The promise is simple to say and hard to do. Custom build hardware with the hyperscaler's software stack, integrate it, test it, add features, harden it, then ship it as a turnkey solution. The key detail is when the work actually starts. It's not an RFP pops out and you bid. The partnership starts at least 6 months before an RFP, in the messy trade-off stage. Signal integrity choices, thermal design, mechanical tolerances, the kind of debates an internal team would have, except now you're sitting in the room with them. And there's a why now that matters. In 2010, the Ethernet switching TAM was around 10 billion. If you build something off the shelf, you can sell to 20,000 customers. If you build something custom for one company, you need critical mass, real volume to justify it. AI CapEx is what creates that critical mass. The market got big enough that building custom for a handful of enormous customers can still create a durable, standalone company. If you want the North Star for what hyperscalers are optimizing for, it's not a philosophical debate. The current need of the entire market is power efficiency and speed of delivery, so the GPUs aren't sitting idle. NextHop just announced what Anshul calls the world's lowest power 51 terabit switch. The bigger claim is what that means at hyperscaler scale. If a hyperscaler were using just their switches, the savings would be somewhere between 50 to 100 megawatts. Not nice, that's we can deploy more compute. And you can hear how the mindset has changed. People used to talk about PUE in air-cooled data centers, like a broad efficiency measure. Now the focus is saving the last 1% or the last 0.5%, because if you're investing at 10 gigawatt a year, 1% is 100 megawatts. This is where networking stops being a line item and becomes a lever. Every percentage point you don't burn in the network is a percentage point you can allocate to GPUs, which is the part that actually prints money. AI networking also isn't one network anymore. In the conversation, it breaks into at least 3 distinct breeds. Scale-out networks for training, interconnecting many GPUs. That used to mean 10,000, maybe 30,000 GPUs. Now some jobs want up to 1 million GPUs interconnected, which doesn't fit in a single building. So you add scale-across networking, connecting multiple data centers together. Different products, different cost, different power profile. You're talking deep buffers, long-haul optics, security issues. Then inference brings a third category, scale-up networking, and they're doing that using Ethernet. Add the classic front-end cloud networking on top, and suddenly you're not building a switch company, you're staring at 20 to 25 products per year, with customers pushing you to prioritize the top 10 that matter right now. That's the hidden reason the market expands from just data center networking into something that can plausibly double. The surface area keeps fracturing, and each fracture is a new SKU with real dollars attached. This business is not for anyone who needs dopamine every 2 weeks. From first customer conversation to pilot deployment to ramp, the timeline mentioned here is 2 to 2.5 years. That's the patience tax. The second tax is domain expertise. Without it, the customer can build it themselves, and many already do. And then there's the operational complexity you don't see from the outside. NextHop has hardware teams for high-speed board design, signal integrity, optics, thermals, mechanical. Software that goes from the Linux kernel up through routing layers, automated test infrastructure, supply chain, new product introduction, compliance, and audit. The company is over 300 people, and it has to act like a grown-up in a world where tariffs go up, tariffs go down is a normal quarter. One detail here was almost comically modern. To claw back overpaid duties and tariffs on prototypes, they used an AI agent in Claude to go line by line through the paperwork. It cost about $500 worth of tokens, and it helped them recover hundreds of thousands of dollars. That's not the main story, but it's the vibe. Even the supply chain team is now quietly running prompts. The most interesting twist in this whole episode is that the innovation isn't only technical, it's cultural. The joint development model works because it's built on transparency with customers. When tariffs and geopolitical risk moved, NextHop didn't treat it like vendor chess. They put the options on the table, admitted uncertainty, and made the choices together. The argument is that the old, "this is my information, I can't reveal it" posture is a false sense of security when your customer is a hyperscaler that can already build everything on their own. So the real moat becomes trust plus execution speed, in a market growing so fast that, as hyperscalers told them, it's not even about stealing share yet. It's about the fact that no single supplier can keep up. If you want the full texture of how Anshul Sadana thinks about building in that environment, and why he believes the spend between now and 2040 will make today look tiny, go listen to Lightspeed VP with Guru Chahel. The question that lingers is simple. In an AI world where power is the scarce resource, what happens when the network stops being plumbing and starts being the throttle?